last and final video for the semester. So the 5D day 2. We want to identify variables and quantities needed to graph the equation that best models the problem. Your learning goals: I can choose the appropriate scaling for the axis of a graph and label for the axes given a real-world scenario. Example 1. So the following graph shows the number of people in millions that have health insurance every year starting from 1992. So in 92, 220 million people had health insurance, and each year the number of people with health insurance increased by 4 million. So this above problem is graphed on the coordinate plane below, and we want to label the axes with the appropriate scale. So what we need to do is figure out what is dependent, what's independent. Now, independent, when we're talking about time, time is 99.9999% of the time going to be your independent variable. Okay? In other words, the number of people with health insurance depends on the year. So the number of people in millions would be your independent variable, or your y-axis, and the year would be your x-axis. Now our graph starts at 1992, okay, and it tells us in 92 220 million people had health insurance. So that's our first data point, 1992 for our x and 220 for our y. And then from there we want to say that, well, each year it increased by 4 million. So if I wanted to make this graph a little bit more readable, I'm not going to try and squeeze, 1993 in here and 94. I'm just going to go up and I'm going to say, okay, I'm going to put 93 there, and I can just add 4 because it increased by 4 million, and then just keep doing that with the same spacing. Well, I suppose that spacing is not perfect on the x-axis. So this would be 92, 93, 94, 95, 96, 97, and then what's important is this over here too, is the 220, 224, 228. They're going up by 4s. And we've labeled it, we figured out the correct scaling, we're good. Final example. So we've got 2 cars traveling north along a road. Car 2 travels at a constant speed of 50 miles an hour for 3 hours. Then it speeds up and drives at a constant speed of 75 for the next hour. Then the car breaks down and the driver has to stop and work on it for an hour, and when he gets it running again, he continues going at 75. While car 1 starts at the same time as 2, but car 1 starts 50 miles further north than car 2 and keeps a constant speed of 40 miles an hour throughout the trip. So we've got this graph below that describes what we just went over, and we need to label the axes with the appropriate scale and determine which line represents car 1 and car 2. Alright, so we're going to make the dependent variable the distance from the starting location of car 1. And this is going to be your time in hours, because remember I said that time is always your independent variable. Okay, so, and this could just be, so we're talking about distance from starting location of car 1, because car 1 started right there. Car 2, it said, started 50 miles further, so that's going to be a little Q right there. So your time is 0, 1 hour, 2 hours, 3. So we're going up by 1 hour at a time. And I would say that car 1 would be the solid purple line because it maintained a constant speed throughout. So notice that its rate of change is the same all the way. Whereas car 2, if you go back, it said that car 2 drove the same for 3 hours, which is right here. And then it sped up. So notice the rate of change from here to here is like that. And then from here to here increases. And then it breaks down, so its rate of change is 0, meaning the car is not going anywhere. And then it continues this same rate of change, and you can see that this and this, these two are the same. Okay? So we've got our 2 cars labeled. Now we just need to figure out how to label our y-axis, or what interval that our grid line should be separated at. And since car 1 started 50 miles closer than car 2 started 50 miles closer than, car 1 started 50 miles further north than car 2. So let's make these intervals of 50 then. And just go up and label them all the way up, and you're good. All done. Just like this semester, all done. So you guys have a test you have a little bit of time to study for, and then you have finals that you need to start studying for very, very soon. So keep that in mind. Don't stop looking at math problems once this test is over. Otherwise, you're going to come back and you're going to have a lot of catching up to do for the final. So enjoy your break, guys. Have a good one. Rest, recoup, and relax, but definitely take a few minutes each day and maybe watch a video, work on a few problems, whatever it is you need to do to stay somewhat fresh.